And there's one more very useful useful aspect of using the useful aspect of data visualization is when I select, suppose, the three of them, and I can also look at, this is basically showing distribution, but the same distribution across different groups. I can use box and whiskers plot to do that. If you see this, you can find this out. It's a very interesting thing happening. This box, right? This box, when you look at this box, how do we read it? It's very important. So just let me, just for the sake of can I twist it? Okay, maybe I can zoom in, right? So if you zoom in, you can look at, let's read this box, what's happening. So let me so you have this cross in between. This cross is nothing but the mean. It is showing the mean, actually, this cross. Let me see if I can draw. Yeah, this cross is where the mean is. This line is where the median, the centermost median, right? This is where the first quartile means if median is at the centermost position, which means at 50th percentile, I mean where half the data, this is the half mark, this is quarter mark, right? This is the 25% percentile position, where 25% or 1/4 of data is in data distribution. So this is the lowest point, right? This is the lowest point of the data. This is the, and here this is the highest point. When you go up, if you scroll up, this is the point highest. And then this whisker, the whisker which you see, which is attaching this point is when at the 3/4 or like 75%. This is what the third quartile, right? Quartile. Median is your center point, right? 50% data is, this is at the middlemost position. This is at the quarter position. This is where 75%. So basically we can say the 50% of the data spread is in this range, and this range is called as interquartile range, IQR, right? This box height, that is interquartile range. This is median. In a perfectly nicely normally distributed data, you would see the cross and the line, they're coinciding, right? But if a data has outliers, so if let's see if I can say detect some outliers. Yes, if you see in the third one, this third one, say, let me let me scroll this so that it can be made smaller. One second. So we can click on this one. Yeah, so we can scroll it out. And what we see is there are outliers in the third one, which is linked in, and because of which you can very clearly see this X, which is the mean, is crossing the median line. Here it is very nicely, the mean and median are exactly the same. So this cross is very nicely intersecting that line, the median line. But here the cross is crossing. It is crossing in which direction? It is crossing in the direction of the skew, or direction of the outlier or extreme value. So these two dots are identified as outlier values, right? So that's where the cross is moving. And how do you identify outliers? Basically there is a what do you call it as, there is a empirical rule which kind of is understood as let me just draw that empirical rule. The empirical rule says that your interquartile range multiplied by 1.5 Q1 minus and Q3 plus interquartile range into 1.5. This is an empirical value obtained via a lot of experiments and experience, and you pick up the basically the value at the first quartile value, right? So that value minus interquartile range into 1.5. Beyond that, that's your cutoff basically. That's my cutoff. Before that, or whatever values are there, those dots, they are labeled as outliers, and anything which is beyond Q3 plus IQR into 1.5 in the positive direction is labeled as outliers. So based on that understanding, the two dots which you see based on the formula of interquartile range into 1.5 and Q3, which is Q3, where is Q3? Q3 is the end of this box. So Q3 is the end of this box. So Q3 plus 1.5 times IQR, which is this. There we cut the this is the cutoff, and beyond that, whatever exists, it is the outlier. That's how we empirically understand that. And the important understanding here is that, or the observation here is that your mean is going to be moving in the direction of the skew or the stretch or the extreme values. Here it is on the positive side, so if the cross is going to be stretched towards, or it is kind of pulled towards the outliers on the positive side. If the outliers were on the negative side, or they were more on the negative side, it's more heavy on the negative side, the cross would be moving on the other side, pulled towards the negative side or the lower side. Right? So when we say positive, because it is on the positive side of the mean, and here which is on the higher side of the mean, and when we say negative, we say on the lower side of the mean. The lower values can also be outliers. Right? That is how we interpret a box and whiskers plot.